Everybody, this is going to be a final attempt for me to try and create a single stub tuner video. It takes a lot of hands to do this, and normally I have student helpers, but during this COVID-19 time I have to do it myself, plus the camera work. Anyway, as you can see on the screen, I've also figured out another way to display data on the network analyzer. I had heard this was possible, but in more than 10 years, 20 years of using this instrument, I had never found the actual buttons to push. But clearly, as you can see on the screen, I am displaying an admittance chart, right, which is the inverse of the impedance chart. We're used to seeing this chart, the impedance chart on the network analyzer, but now I'm going to display the admittance chart, which is quite useful in doing single stub tuners. And so we see the classic red Smith chart for impedance, and if I want to display green for the admittance, I can do that. So the first step in the single stub tuner process is to start with a load that is not matched. So I gave you this document, posted it last week, and this is a 200 ohm load. On it actually at 833 megahertz, my favorite frequency. It actually displays as 166.45 ohms minus J 72 ohms. It's in the bottom half of the chart, so it's capacitive. The other components that are used in the single stub tuner are the adjustable line, which is this unit here, which can be, I can pull the connector so we can adjust this line length. That moves us around the circle in a constant VSWR circle. And then the shorted stub that we used to determine the matching stub, we call it. The challenge on this project is a little bit the setup. So initially, I have to start out with measuring the load itself, which I did, right? But now I have to reproduce that position based upon using a setup with the T connector and the adjustable line. And so if you think about it, I can cancel out the stub by making it appear as an open at this bridging point or paralleling point, but that won't really tell me what the impedance is for this transmission line. So the easiest way to do that is to cancel out this stub, making it look like an open, is to actually put a match on the end of the transmission line. Then I can adjust the stub so that the transmission line appears as a match. When I've done that, then I know this stub is canceled out, and then I can go back with my unknown load and set up the system for the impedance that originally started as this value by itself. That was the start of the process. So I'll set up for that, and I'll show you a couple short measurements about that. So as you can see, I've set up for my load 162 ohms minus J 71, almost the same as the printout, and we know we're in the right location. Now I've connected a cable and calibrated the end of the cable, so that is my impedance I want to come back to once I add the other components. But the first thing we're going to do is adjust the stub to act like an open circuit, and then we'll do that with a match on the load end. So I've connected my 50 ohm load, calibration load, to the stub tuner, and I've adjusted the stub and so that I get almost a direct match. You can see 50.43 ohms minus J milliohms. So that is very close to the center of the chart. So I know that I've now canceled out the effect of the stub. Okay, as you can see on the chart, I have put the 200 ohm load on the length of the transmission line. So now I have the whole setup, and I've adjusted, and I'm back to, I've adjusted the length of the sliding line to, now I'm at 171 minus J50. Now, I'm going to show you how that effect occurs. So when I adjust the length of the transmission line, you can see that I move in a circle, a constant VSWR circle, and you can see I can move in a circle around the Smith chart. I'm not going to be able to go all the way around because of the frequencies involved and the length of my adjustable line, but you can see on that point I'm adjusting over to the almost 14 ohms. If I go the other way, this direction is towards the load. So it moves in the clockwise direction because I'm making the line shorter, and that's I can go about around the chart completely and a little bit more. But we want to get back to that point, which was where we were with the original 200 ohm load here. And that value was my 166 minus 72. So I'll adjust it as close as I can get it. So I'm at 165 minus J50. I'll fine tune it a little bit. It's not going to be exactly the same as the original load because I've introduced a little bit of extra impedance with the line. But that's pretty darn close. Okay, now I'm going to take advantage of my Smith chart display in admittance, right? Because I want to move on a constant radius circle until I get to that G equals 1 circle, which you can't see right now. But displaying things in admittance mode, we're going to be able to do that. So first off, I need to tag the position I'm at, so when I adjust, I'll be able to know how much line length I've added. So I'll do that first. Okay, so I've done two things. I've changed to admittance mode, right? And so you can see this value is now 5.3 millisiemens plus J 1.7 millisiemens, because we're in the green chart, so the bottom is now positive J, right? Now I've changed the color to green to remind us we're in admittance mode, and now we're going to move on this constant radius circle until we touch this G equals 1 circle. So we'll do that adjustment. Normally I have a student to help me, so we'll see how this works. I have marked the transmission line so I know the point at which I'm at. It's very nice to be able to have this admittance display because I'll be able to tell very exactly that I'm in the right location. And I'll know that because remember that has to be 20 millisiemens, which is what it's reading. So I've tagged my transmission line, and now I'm going to adjust my stub. So the stub, as I adjust it, I should be moving on that G equals 1 circle. Now if you adjust one direction, you're going to move over towards the short. So at that point I'm acting like a short. Almost, it's a little off, but I continue around until I get to this point here. And the value I'm at is a value of 23 millisiemens, and minus J, so I'm just above. So I did a little bit of fine tuning on the movements. It's hard to do it and film at the same time, but you can see I'm at 20 millisiemens and 0.1 or millisiemens, point something millisiemens. So I'm very close to 50 ohms. I'll switch over to impedance display so we can see that. So I have switched back to obviously red and impedance mode, and you can see I'm up here at 49.77 ohms minus J 83 milliohms. So that is an excellent match, all done by lossless transmission line adjustment and a stub tuner. Okay? So I will now record the values of my stub value and the amount the transmission line length was added, the L1 and L2 value. So here is our load, here is the transmission line. The difference in those two tape points is how much transmission line I added. So I lined up this one with 30, and this looks like it's maybe around 55.4 centimeters. 5.4 centimeters is the adjustment for L1. Here is the adjustment for the stub. I lined up with 20 over here, and this is about, looks like 32.8 or something. So that would be a difference of 12.8. Now, you have to remember, we started out with this as an open stub to cancel out for the matching. So the frequency is 833 megahertz, so lambda is 360 millimeters. And an open and a short will have a difference of 9 centimeters. So that 12.8 centimeters, or that would be equivalent to 128 millimeters. I need to subtract 90 from it, or 9 centimeters, because I need to go from an open to a short. 128 minus 90 is equal to 38. Now let's check those values on the Smith chart program. So I've done the Smith chart program. We started out here with a load that was 166 minus J72. That was the value we measured originally. We moved on the constant radius till we got over to the G equals 1 circle. And the length of that transmission line was supposed to be 56 millimeters. And I believe I said that that was equivalent to, at that point, was 54 millimeters. So we're within a millimeter or so of that value. The stub length was supposed to be 33.7 millimeters. Now we measured, on there we measured 128 minus 90 makes 38 millimeters. And in the transmission line program, this is listed out as a value of 33.7 millimeters. So that's the single step tuner, a little complicated to set up, and in reality, this sliding contact is really the big problem. The sliding stub up here is actually pretty well behaved, but this sliding series contact was the main reason this technology really was abandoned for double stub tuners and the like. All right, that's the single stub tuner.